Modern parallel computer hardware is complicated. We have multiple cores on multiple chips connected to accelerators, and if this weren't enough, we duplicate the whole thing thousands of times to build huge parallel computers. How do we leverage this vast computing power? Which programming models should we choose? What are the performance implications? MPI+X is a general term describing the way these problems are tackled today. We combine the message passing interface with something that allows us to use the parallelism down to the core level. But a programming model, whatever it's called, will not make all problems vanish automatically. This starts already at the node level, where compute resources are put together in complicated ways, making it hard for any programming model to figure out how to run the code in the most efficient way. If nobody cares where threads and processes are running, chaos will emerge. Programs will not show reliable, repeatable performance. The concept of affinity is crucial here. How do you make sure that your stuff is running where it should be? If you combine two programming models, the options multiply. Even with the standard combination of MPI plus OpenMP, there are many choices. Should you run one MPI process per node, or two, or more? How should you distribute the threads among the cores and sockets? Many users get lost in complexity and just ignore those questions. But this leaves a lot of performance potential on the table. Going beyond one compute node, we hit the problem of how to handle communication. Everyone uses MPI for that, but how can we do it in the most effective way? For example, we could use OpenMP threads to overlap communication with computation, but this makes the program more complicated, so there's a trade-off between performance and programmability. A whole new world has opened with affordable accelerators entering the scene. Today, everyone knows that a GPGPU or a Xeon Phi will not give you a 100 times speedup, but it's enough to make people think seriously about using them. But how? And how do we make sure that our programs will still compile and run in 5 years? Although MPI+X appears to be an attractive solution for all of these issues, there's still a huge space of possibilities. Even when looking at the node level alone, you may consider using pure OpenMP, or pure MPI, or MPI with a brand new shared memory extensions, or MPI combined with OpenMP. And we're not even mentioning the gazillion of other programming models that haven't made it yet into the mainstream. Adding accelerators only makes things worse. Don't let your head explode. Learn how to take control. Visit our half-day supercomputing tutorial on MPI+X, hybrid programming on modern compute clusters with multicore processors and accelerators, in which we cover all of these questions and more.